Okay, so in the earlier session, the first session of the introduction, we had studied about what is control system. We had seen, what is the literal meaning, where we see control systems around us. Okay, what are the common terminologies that we use in the field of control system? All these things we have studied in the introductory class, just to give you a flavor of what actually control system is. Okay, now moving ahead, we are going to, in today's unit, we are going to talk about the open loop and closed loop control systems. Okay, this is again one of the basic terminologies which we use in the field of control system, which is open loop and closed loop. Okay, now open loop and closed loop is very important domain because these are very important when we are analyzing the system, the plant individually or the plant along with the controller as a whole control system. Because open loop it gives us some of the properties when we analyze in the open loop, some of the properties, inherent properties of the plant can be studied. And then there is a concept of negative feedback, which makes the system into a control closed loop system. And when we give it a negative feedback, we have various advantages of having a feedback loop or a feedback system, which increases, at times it is increasing the trajectory tracking of the system, you can say, or you can say the set point tracking of the system. Sometimes it is also improving the stability of the system, so and so forth. So there are certain merits of having a closed loop system. So we are going to talk about the open loop and closed loop control systems in this particular session. And then we are going to start talking about the dynamic modeling of the various kinds of systems that we have. Okay. So open loop control system, now this is the one in which the output has no effect on the control action. If you see the example given here in the figure, you have suppose you want to dry the clothes. Okay, so in this case, what happens is you have a timer. Okay, you have some heating elements, and further you have some clothes which are subject to the heat that is being generated by the heating element. Now, in this case, the video that the figure that you see in on the slide, in this case, there is no comparison of output and input at any time. Okay, so what you can do, best possible way, what you can do in this is you set a timer. Okay, एक अंदाजा लेकर के in what time the clothes will be dried up, you can set a timer. Okay, and as soon as the timer starts, the heating elements will be switched on, some heat will be generated, the clothes, they will be subjected to that heat, and after a particular time duration, suppose it was 10 minutes, after 10 minutes the heating elements will get switched off, irrespective of whether the clothes have actually dried or not. Okay, so this is an open loop control. Control is there definitely because after certain time it is going to be switched off on its own. So control is there, but it is open loop. That means the input, or you can say the reference input that we are giving and the output that we are getting, there is no comparison between the two. हम किसी भी टाइम इंस्टेंट पर ये नहीं चेक करते कि आउटपुट जो हमें मिल रहा है क्या वो डिजायर्ड आउटपुट है या नहीं, जो एक्चुअल आउटपुट हम चाहते थे वहां तक हमारा सिस्टम पहुंचा है या नहीं पहुंचा है. ओके, हमने कुछ कंट्रोलर का कुछ लॉ सेट कर दिया, जैसे इस केस में हमने टाइमर सेट कर दिया, वो सिस्टम उस कंट्रोल लॉ के हिसाब से बिहेव करेगा और एक टाइम के बाद वो ऑटोमेटिकली बंद हो जाएगा. हमें नहीं पता कि एक्चुअल टारगेट अचीव हुआ है या नहीं हुआ है. Meaning to say whether the clothes they actually dried, if they have dried to what extent, are they completely dry, are they partially dry, we don't know all this. Okay, and if suppose there is some environmental factor, okay, or some disturbing factor coming into picture, for example, there is suppose also external heat or the ambient temperature sometimes might be very cool, sometimes might be very hot. Okay, so if that ambient temperature is beyond a certain limit such that it starts affecting your system, यानी clothes जो है अगर system sometimes if the ambient temperature is also something equivalent, तो ambient temperature भी clothes को dry करने में help करेगा. So your heating element actually doesn't need to produce that much heat. But अगर आपका ambient temperature बहुत low है, humidity है, moisture है air में, तो heating element को ज़्यादा heat produce करने की जरूरत पड़ेगी to dry the same amount of clothes. But in this case, the controller जो कि इस केस में हमारा टाइमर है, उसको ये बातें नहीं समझ में आ रही हैं because we are not taking any feedback. Okay, आउटपुट में जो भी परफॉर्मेंस हो रही है हम उसको मॉनिटर नहीं कर रहे हैं. Okay, we are not taking the feedback from the output and comparing it with the desired value. So in that case, if there is some environmental factor, some disturbance factor coming into picture, the controller cannot do anything. The controller can simply perform the action whatever has been set initially, and once it performs that action, it will stop. Whether you have achieved the final output or not, the controller is not concerned about that. And there is no way in which we can actually monitor whether the final output has been achieved or not. So this kind of a configuration that you see, this is open loop control. Okay. So ye configuration, this can be useful only for small systems where everything is predetermined. When you know that okay, whatsoever type of situation might be, if I set the controller for 20 minutes, I'm sure that it is going to get dried up. So if all the data, everything pre-hand, and you know that this much timer is going to work, then of course you can use this kind of a control system. But wherever there are the changing conditions, wherever there are dynamic conditions, there it is not possible to use open loop control for achieving the desired task. And secondly, it might be very inefficient in terms of energy. Agar isi ko, if we connect it in feedback, and we know that sometimes if ambient temperature is also very hot, that is also contributing in the drying of the clothes, why my heating element should go on working extra? I'm losing energy, I'm losing power. So instead of that, if I have a feedback, and at every time instant, if I can measure the dryness level, maybe timer jo maine 20 minutes ka lagaya tha, if ambient temperature is very high, it might finish the job in 10 minutes. If it is finished in 10 minutes, the heating element should get switched off. Okay, so open loop control can be used in certain scenarios, but it might not be very effective. And secondly, it might not actually give you any desired output value, right? So this kind of structure that you see on your screen, where there is no monitoring, or you can say where there is no comparison of the output, you can say obtained output with the desired output. Such kind of a configuration is called the open loop control. In this case, the output is not fed back to the input. There is no comparison between the obtained output and the desired output. And so consequently, there is just one prefixed control law which is going to perform its action, and then it is going to stop irrespective of whether the desired output has been achieved or not. Okay, so this is open loop control. Now in the same system, if I add a sensor, suppose I can add a moisture or a humidity sensor, which can measure how much moisture is still present in the clothes. Then what will happen? Now this controller is supposed to, let me consider this as an on-off controller. So what will happen when it is actually measuring the output, when it is measuring the dryness level of the clothes, and some desired dryness you have set, okay, given to the controller. Now what happens? It at every time instant, it takes the value from the output, that means the actual dryness level, it compares it with the desired dryness level. If there is some error, okay, that means if still there is moisture present, controller becomes on. Or you can say controller sends an on signal to the heating element. The heating element is switched on, it produces heat, and the clothes, they start drying again. Again, at next time instant, it is going to measure the dryness level, compare it with the desired dryness level. If there is still some error, heating element should remain on and the clothes should continue to dry. The moment the output dryness level matches the desired dryness level, that means the error now becomes zero. When I say compare, it is subtracting, because this is negative feedback. Whatever output we are getting, we are subtracting it from the desired input. Okay, so the moment this error becomes zero, that means desired dryness and actual dryness, the moment it becomes zero, controller understands that the desired task is done. It gives an off signal to the heating element and there is no more heat being produced. So in this, what happens? The heating element is going to work only till the time it is required. Neither it is going to work extra and waste energy, nor will be your output level settle down beyond or before the actual desired level. Okay, so this configuration that you see, this is called closed loop control system. Okay, so closed loop control systems, they are feedback systems where the output is fed back to the input in an out of phase. Out of phase means negative. Okay, so the term out of phase is actually used in the control system to indicate negative feedback, or you can say opposite feedback. So if desired level was a positive quantity, the actual output that is being fed back will be a negative quantity. Okay, remember there are positive feedback systems also, but very rare. Only in certain exceptional cases do we use positive feedback, because positive feedback के case में sometimes there is a possibility that the energy of your system can go on multiplying and it can go beyond a limit. Okay, it can lead to instability of the system. Infinitely energy increase हो सकती है. So positive feedbacks are used only in certain specific kind of systems, जैसे जहां हमें oscillations produce करनी है. Okay, oscillator बोलते हैं उसे हम. If in such kind of systems हम positive feedback use करते हैं, we'll come to that in the later sessions. But mostly in the systems of this kind, where we are controlling the performance of certain equipments or certain elements or actuators, we are using the negative feedback configuration. Okay, or you can say the out of phase feedback configuration to produce an error actuating signal. This signal that is produced, that is the error signal that is produced, that on the basis of that error signal, controller decides what actuating signal is to be produced, and that actuating signal actually drives the system in such a way so that the output becomes closer and closer to the desired output. Okay, the actual output becomes closer to the desired output, and this signal goes on continuously working till the desired and the actual output become equal to each other. Once they are equal, the error becomes zero, the actuating signal will stop. Okay, so this is closed loop control system. Now here you can see one example of closed loop system. Now, closed loop control systems, they derive their accurate reproduction of the reference input from the feedback comparison of the output with the input. Any difference in the actual and the desired output is automatically corrected. Now, if you see this figure is of one system where we want to maintain the height in the tank as h. Okay, you can see there is a tank at the bottom which is having a float. Okay, and there is a outlet valve V1. On the top, you can see there is an inlet valve V2 from where the liquid is coming into the tank. From V1, the liquid is going out of the tank. And the idea is that by balancing V1 and V2 valves, we need to maintain a particular height in this tank. Okay. Now, capital H is actually the desired height. Small h is actually height in at any particular time instant. Okay. So what we do when this float, you can see float is over here in the dashboard. There is this is kind of an a movable float. This is, you can see that over here on the top, this float is just put in the dashboard, but it can move up and down. So as the liquid level or in the tank will move or it will change, this float is going to move up and down by the buoyancy force. And on the top, you can see we have given it that much leverage so that it can move in to and fro, or you can say up and down movement. And this
There
float,
is liquid in dashboard also.
yes, you can have liquid in dashboard, and sometimes it can be, you know, usually this is incompressible liquid to maintain the, you know, movement of the float that we have. So usually this in the dashboard that you see, this is an incompressible liquid to maintain the movement of the float. Okay, so now this particular rod that you see over here from coming from the float is actually connected to an electrical circuit. Okay, this symbol that you see over here, this is a potentiometer, or you can say a variable resistance. Okay, these two A and B that you see, this is variable resistance. So the concept over here is, this is a resistive element, this zigzag symbol that you see, this is a resistive element, and this particular tap, the arrow that you see, this tap, at whatever point you put it, okay, that much resistance from one side, that will be counted in the circuit, and the rest will be eliminated from the circuit. So ye jo aap dekh rahe ho, error detector, or what you can say potentiometer, in this, on both the sides we are having a variable resistance. Okay, and variable resistance is connected with a movable tap. This tap is going to move to and fro, or in this case you can say up and down, with respect to the float. जैसे लिक्विड का हाइट चेंज होगा, फ्लोट मूव करेगा, फ्लोट मूव करेगा तो उससे ये टैप मूव करेगा रेजिस्टेंस पे। जब ये टैप मूव करेगा, इस पर्टिकुलर रेजिस्टेंस और इस रेजिस्टेंस में जो डिफरेंस आएगा, उसकी वजह से इफ यू सी वी आर हैविंग वन सिग्नल कमिंग फ्रॉम बी एंड वन सिग्नल कमिंग फ्रॉम ए, देयर विल बी अ वोल्टेज एरर सिग्नल प्रोड्यूस। ये पॉइंट भी एक वोल्टेज प्रोड्यूस कर रहा है, और ये पॉइंट भी एक वोल्टेज प्रोड्यूस कर रहा है। पॉइंट ए को हमने ऐसे वोल्टेज पे सेट किया है, which is the voltage which will be produced when actual height is achieved। यानी कि जब इसमें एक्चुअल हाइट h जो हम चाहते हैं, जब वो अचीव होगी, तो जिस पर्टिकुलर पॉइंट पे ये b पॉइंट होगा, उस टाइम इसकी जितनी वोल्टेज होनी चाहिए वो हमने पहले ही a में सेट कर दी है। इसका मतलब हमने रेफरेंस जो हाइट है उसको वोल्टेज के टर्म्स में एक तरफ हमने सेट कर दिया है। सो दिस बिकम्स द रेफरेंस इनपुट फॉर अस, and this b point is giving you the signal which is dynamic, that is at every time instant। जैसे जैसे फ्लो इसमें आएगा, वैसे फ्लोट के मूवमेंट की वजह से यहां से भी एक वोल्टेज सिग्नल प्रोड्यूस होगा। और ये दोनों जो वोल्टेज सिग्नल्स हैं, ये वोल्टेज सिग्नल, ये जो आपने पावर एम्पलीफायर का ब्लॉक देख रहे हो, ये एक्चुअली एक कॉन्फ़िगरेशन होता है ओपैम का, जिसमें आप सिग्नल को सब्ट्रैक्ट कर सकते हो। ओके, सो दीज टू कैन बी सब्ट्रैक्टेड, and finally there will be some error voltage generated. That error voltage will drive a motor which is linked to the valve, and the valve will either open or close depending upon whatever error voltage is being produced from here. Okay, so of course the speed of motor is proportional to the voltage that you give to the motor. So this, I don't know whether you have studied this concept or not, but in the lab we are going to have one experiment in which you will study the relation between the voltage, the current, and the speed of the motor, even the position of the motor. Okay, now this motor driver, this motor drive, motor depends upon type of application. It can be a simple servo motor, it can be a stepper motor, that depends upon what kind of application you have. Sometimes valve ऐसे होते हैं जिनको एक पर्टिकुलर एंगुलर मूवमेंट ही हम दे सकते हैं, यानी कि हर बार वो एटलीस्ट 5 डिग्रीज को घूमना चाहिए। तो इन दैट केस हम स्टेपर मोटर यूज करते हैं, बिकॉज स्टेपर मोटर की जो मूवमेंट है वो एक डेजिग्नेटेड स्टेप्स में होती है। अगर ये फ्री टू मूव है वॉल्व हमारा, तो हम एक सिंपल सर्वो मोटर यूज कर सकते हैं which can give an analogous movement to this particular valve V2, right? So here you can see in the system, this is kind of a feedback system। valve V1 और valve V2 जो है, ये दो वॉल्व्स हैं हमारे, these are the actuators, okay? एंड इसमें हमें एक लिक्विड हाइट को मेंटेन करना है। सेंसर जो है वो ये फ्लोट है, यहाँ पर एक ट्रांसडक्शन एक्शन हो रहा है, यानी जो मैकेनिकल मूवमेंट था फ्लोट का, उसे हमने वोल्टेज में चेंज कर दिया बाय अटैचिंग इट टू अ वेरिएबल रेजिस्टेंस। ओके, एंड जो रेफरेंस सिग्नल था हमारा, रेफरेंस हाइट को भी हमने वोल्टेज के फॉर्म में कन्वर्ट करके एक रेफरेंस सिग्नल जनरेट किया है। उन दोनों को हम हर टाइम इंस्टेंट पे कंपेयर करते हैं। जब हम कंपेयर करते हैं तो एक एरर वोल्टेज जनरेट होती है। वो एरर वोल्टेज अपने प्रोपोर्शनल एक मोटर को ड्राइव करती है, मोटर का एक मैकेनिकल एक्शन इनिशिएट करती है, और वो मोटर कॉरेस्पॉन्डिंगली वॉल्व V2 को कनेक्टेड है, जो V2 को ओपन या क्लोज करता है, पार्शियली ओपन करता है, पार्शियली क्लोज करता है, डिपेंडिंग अपॉन दैट हाउ मच द एरर सिग्नल वाज। जैसे जैसे ये एरर सिग्नल कम होता जाएगा, मोटर की स्पीड भी कम होती जाएगी, वॉल्व का जो पोजीशन होगा वो धीरे धीरे क्लोज होते होते इट कैन क्लोज व्हेन दिस हाइट इज अचीव्ड। अगर मेरा V1 डायनेमिक है, यानी V1 कंटिन्यूअसली फ्लो कर रहा है, तो ये एक ऐसी पोजीशन V2 की फाइंड आउट करेगा जहां पर इनफ्लो और आउटफ्लो बराबर हो जाएगा। एंड एट दैट पॉइंट ऑफ टाइम, ऑल्दो both the valves are working, but this error will be still zero because inflow and outflow are equal, and that height is constantly maintained in the liquid. So this is actually a practical example of a negative feedback control loop system. Now let me know if there is any doubt in this.
मैम जो डैशबोर्ड में लिक्विड है आपने बोला उस पे भी डिपेंड
Okay. So feedback, we have studied that how the feedback is working in the closed loop. Of course, we have certain merits and demerits. Merits is it is reducing the sensitivity of the system to parameter variation. Now, in the next 1 or 2 lectures, we are going to study this mathematically, that when you have a feedback or when you have a closed loop system, mathematically we can prove that system parameter में जो variations होते हैं उसके तरफ सिस्टम जो है वो लेस सेंसिटिव हो जाता है। यानी अगर सिस्टम के पैरामीटर किसी भी वजह से थोड़े बहुत फ्लक्चुएट भी करेंगे तो भी सिस्टम आउटपुट को मेंटेन फिर भी कर लेता है। ठीक है, फॉर एग्जांपल कुछ इनर्शिया चेंज हो गया, कुछ वियर एंड टियर ओवर द पीरियड ऑफ टाइम आना शुरू हो गया, या किसी वजह से, जैसे अब इस केस में लिक्विड था, लिक्विड की कोई प्रॉपर्टी चेंज हो गई, ठीक है, थोड़ा बहुत विस्कोसिटी चेंज हो गई, या उसकी जो स्पीड ऑफ फ्लो है वो चेंज हो गई, तो up to a certain limit this feedback configuration by itself it gives robustness towards those variations. So that we can also prove that mathematically. We will be doing that in the subsequent lectures. So one merit of feedback is that it will reduce the sensitivity of the system towards parameter variations. It reduces the effect of noise and disturbance on the system, produces beneficial effect on bandwidth, impedance, transient and frequency response. All these terms are going to come up in the next unit when we are going to talk about the transient response analysis. So basically you can say that it gives you a better response as compared to the open loop configuration. Okay, but at the same time we have certain demerits. That is, it increases the number of components. Of course, you need a sensor. It has to be connected in feedback. Okay, it affects the gain of the system. Gain means the driving power of the system, because feedback में जब आप लगाओगे additional components आ जाएंगे, उन components को drive करने के लिए थोड़ी सी energy आपकी उसमें भी waste हो जाती है. So the energy that you are giving the system to drive towards the desired output, that gets affected to a certain extent. Okay, and it can introduce a possibility of instability in the system. This particular third point is actually only for some rare cases. Most cases में feedback जो है वो stable करता है. अगर आप उसको positive feedback में ले जाएंगे, then there is a possibility of creating an instability also. Okay. And another important point, yesterday somebody had put up a question that when we are using a feedback, we are using the sensors, there will be a noise because of those sensors also. ये किसने पूछा था? Is that student present?
Yes, ma'am.
So now that point is very, very important, and that is very true, that whenever we are using certain elements in the feedback, mostly sensors, those sensors also produce some noise. Okay, so first thing is that those noise elements or the noise that is coming from the sensor is not of that prominent magnitude that it can affect your system. And at the same time we have certain filters. एक होता है कंट्रोलर, which is actually you can say the whole soul powerful component जो आपके सिस्टम को ड्राइव करता है. एक होता है फिल्टर जो सिर्फ सिग्नल को filter out करने के लिए हम लगा देते हैं. So mostly what we do is whenever we are using a sensor, in today's time mostly sensors की noise हम identify कर चुके हैं. Okay, in the literature you can understand what kind of sensor is expected to produce what kind of noise. So sometimes what we do, we identify that kind of noise, design a suitable filter, and जो sensor signal देता है उसके आगे हम एक filter लगा देते हैं. उससे वो जो noise, unwanted noise उसने ambience से उठा ली थी, वो उसको filter करके सिर्फ आपका जो desired signal होगा उसे वो comparator में feed कर देगा. ठीक है. तो although आपका system becomes a bit complex, there is a tedious task of designing a filter, but that effort is very, very small as compared to the benefits that you are getting from the feedback. So इसलिए हम feedback, we always prefer feedback. Is the doubt clear now?
Yes, ma'am.
Okay.
Yes,
So,
ma'am.
yes, anything else? Okay, so this is now the earlier examples that I had shown you, like this one and this one. You can see that we have a controller and we have a process plant. So this is the open loop and the control, open and closed loop control system. Another thing is open and closed loop system only. So this, the figure that you see on your screen, this is another kind of type of analysis that we can do. One is you have a system, no controller, nothing. You just give it some input and see what output it is giving you. This is called open loop analysis. And on the other hand, again, there is no controller, nothing at all. You simply add a sensor and put a closed loop, make it closed loop. The error signal is directly fed to the system. And then you see how the output is being affected. This is called closed loop analysis. So sometimes it so happens that even if controller is not there, you make the system closed loop, the performance gets improved. That is also, it happens sometimes in some of the systems. So this figure that you see, this is called open as well as closed loop configuration for the analysis of any system, right?